Hello, wonderful person, this is Anton, and today we're going to dive back into one of the most enigmatic mysteries in the history of observational astronomy, the by now infamous WOW signal. The intense radio burst detected back in 1977 that for several decades now has puzzled astronomers and of course fueled our imagination about the potential source, while also bringing up the very important question of, are we alone in the universe?
Well now, Anton kicks this off with the WOW signal, and it never ceases to fascinate. Few astronomical events have so neatly captured both public imagination and scientific curiosity. That lingering "are we alone?" question makes each new analysis feel momentous.
Because even today, this is technically one of the most intriguing unexplained radio phenomena ever detected by astronomers. But here's the thing. After nearly 50 years, several new, detailed analysis-based papers, mostly focusing on reanalysis of the initial discovery, uncovered several somewhat surprising discoveries, providing a comprehensive re-evaluation that significantly changed some of the previous assumptions about the signal, and of course about what potentially created it. And so in this video, let's discuss some of the most recent discoveries, but first I guess let's start with the initial discovery and what we've known so far for many years. And so I guess here, let's start with a quick refresher. This was detected on August 15, 1977, and it was originally heard by this telescope right here, OSURO, Ohio State University's Radio Observatory, more commonly referred to as the Big Ear, the telescope that joined the newly formed SETI in order to try to discover signals from extraterrestrial intelligence. And well, to date, this was the most incredible and actually the only such discovery involving an incredibly intense narrowband radio signal, showing a lot of attributes expected from a technological transmission from outer space. And so when astronomer Jerry Ackman reviewed the original data that you can see printed right here, he simply wrote WOW. Although here the common misconception is that these letters and these numbers were the actual message. It's not. Here the letters and the numbers simply represent the total intensity of the signal. And in this case, it was super intense.
Fascinating, considering the historical context. The Big Ear and Jerry Ackman's famous WOW annotation remind me of how often science advances through serendipity. The intensity alone, without any decoded message, was enough to keep SETI alive in popular memory.
But what exactly made this so unusual on top of intensity, and why are we still talking about the signal even after 50 years? Well, first of all, the signal here lasted for approximately 72 seconds. And this is actually the result of the night skies drifting due to the Earth's rotation, with the intensity in this case following the expected Gaussian beam pattern that you can kind of see summarized right here. And so there was a gradual increase, then a peak, followed by a decrease, expected from a distant stationary object of extreme radio intensity. But crucially, it was also detected in the 1420 MHz frequency, also referred to as the hydrogen line, something that back then was potentially expected to be used by any extraterrestrial intelligence that would want to communicate. Yet despite follow-up observations, and despite additional observations looking at every other object in the galaxy, so far no additional signals have been ever discovered again. And so because of this, for decades, there's always been the limitation when it comes to the actual physical data. We just did not have that many examples. But more importantly, it was commonly believed that most of the original data from the Ohio SETI project has been lost forever in 1998. That's actually when this observatory was officially closed.
Curious, isn't it? That perfect Gaussian shape and the hydrogen line? SETI researchers practically dreamed of such characteristics. Yet its singularity remains vexing. In science, one-off events are tantalizing but maddeningly resistant to firm conclusions.
But turns out that this was maybe not the case. Between 2006 and 2017, Mark Abel managed to photograph over 75,000 printouts from the so-called N50CH software, the software that was also responsible for producing the WOW signal. And here he was able to create a 1.24 terabyte dataset that also included the observations from 1977 to 1984. And so then, by using the modern computing technology and especially optical character recognition, scientists behind this recent study were able to meticulously transcribe and analyze decades and decades of observations from this radio telescope, in the process discovering several additional features of the signal by comparing it to everything else.
My goodness, the sheer dedication to digitize 75,000 printouts feels almost heroic. It's a reminder that archival work can yield as many breakthroughs as new telescopes. Sometimes rediscovering lost data is as powerful as fresh observations.
And the first revision here was the location, because previously there was just a bit of ambiguity about the exact location, since this particular antenna contained two separate horns that observed the same region with a 3-minute interval. But the WOW signal was only discovered in one of them. And in this case, it was actually not clear which of the horns. And so the new reanalysis seems to have established that the new location is slightly more narrow and slightly displaced from earlier estimates, specifically about 7.24 arc-minutes away from the original source, which allows future studies to possibly locate its origin.
Hold on. That refinement of position by just a few arc-minutes matters hugely. Astronomers live on precision, and narrowing the source location could someday let a new array target the exact patch of sky, an exciting prospect after decades of ambiguity.
The second surprise here was the total intensity. Apparently the signal was even stronger than we initially thought. Previous estimates suggested that the signal was maybe about 54 to maybe 200 Janskis, but the new analysis using new calibration and cross-referencing from other sources suggests that the signal was at least 250 Jansky in total. But as you can see from this graph, that doesn't actually make it very strong compared to what we already know. So let's actually take a brief moment to briefly discuss what 250 Jansky would actually mean. In astronomy, this is a unit of spectral flux density, but that's very often used for determining intensity of a signal.
Interesting angle. Scientifically speaking, recalibrating from 200 to 250 Janskys raises the bar a bit. For context, though, in cosmic radio terms, that's modest. But the fact it emerged at such a precise frequency still makes it stand out from natural background clutter.
And 1 Jansky is actually super small. It's like 10 to the power of minus 26 watts per square meter per 1 hertz. But that of course would not make much sense, so let's compare it to something more realistic. Let's start with the sun. When it's super quiet and has no emissions, it usually emits approximately 1000 Jansky at 20 megahertz. In comparison, the Milky Way, or essentially the entire structure of the Milky Way visible from our own planet, usually emits approximately 1 million Jansky. But intriguingly, if there's a smartphone roughly around 1 kilometer away from the radio antenna, technically it can emit up to about 110 million Jansky if the signal is intercepted. And so here 250 Jansky is practically nothing. But when it comes to distant radio sources, it technically is quite a lot. This is something we expect from various central Milky Way regions and certain bright radio sources, such as some of the strongest radio sources in the night skies, for example magnetars or even powerful quasars. As a matter of fact, there are only a few astronomical radio sources that are known to emit such a high-level signal, making this event even more exceptional compared to what we previously thought.
Gosh, this really highlights the complexities of scale. A nearby phone outshines the galaxy, yet from light years away, 250 Janskys hints at something extraordinary. Context is everything in radio astronomy, and here the rarity is what truly elevates the signal.
And also raising the question of whether other radio telescopes might have accidentally seen it too. While at the same time, its frequency may have also been slightly different, but different by just a tiny decimal point in terms of megahertz. And though at first this may not seem important, it's important in terms of the analysis of where this came from. Because here the implication is that wherever this was, it had a much higher radio velocity than previously assumed. And that's because only Doppler shift, or redshift and blue shift, could have affected the frequency.
Right then, examining the evidence closely shows that a minuscule frequency shift reveals motion. Tens of kilometers per second. Doppler corrections often make or break astrophysical claims, and here they underscore just how dynamic the source environment must have been.
And here this suggests the object was moving toward the sun at approximately 84 kilometers per second, and also approximately 74 kilometers per second in the so-called local standard of rest reference frame. And that particular part was discovered through the reanalysis of the original data. Apparently here there might have been a small mistake. A mistake that was not actually seen at first, and that was a result of some kind of a software update that happened back in 1977. And so by discovering these new properties, researchers have now come up with a few more explanations for where this possibly came from and for what actually caused it. Like in previous studies, pretty much most of them have been so far ruled out completely, and that includes potential alien civilization communication, or even communication from planet Earth involving satellites or some other natural source right here on our own planet. With these signals beam pattern implying that it very likely came from a very far point beyond Earth's orbit, and of course appearing stationary in the celestial background. And also because this particular frequency has been protected by astronomers for decades now, with 1420 MHz basically being the forbidden frequency, here it's almost certain that this came from outer space. But even when considering various harmonics, such as the second harmonic of 710 MHz or the third harmonic of 473 MHz, which is actually used by some TV stations, here it's been concluded that none of the TV stations or none of the radio transmission devices were using any of these signals in Ohio at this time. And most importantly, there were no known satellites in the location in August of 1977.
Not to nitpick, but historically, terrestrial interference has confounded radio astronomy again and again. Yet the hydrogen line's protected status here is a strong safeguard, making it persuasive that this was no Earth-based artifact but something genuinely cosmic.
And even any secret satellites by, for example, Soviet Union, which very often use what's known as the Molniya orbit, would not be able to create a signal lasting for 72 seconds. It would be much faster. This could also not be solar activity, because in August of 1977, the solar activity was generally very low, and this was unlikely to be some kind of an internal error or a software glitch, because the analysis of data for decades and decades afterwards and before that discovered nothing similar. The signal was indeed unique, and none of the previous detections showed anything similar. And so what could it then be? And what's the most likely explanation that so far most scientists seem to agree with?
Blimey, that revelation packs a punch because once we've excluded the sun, satellites, and glitches, we're left with a bona fide astrophysical phenomenon. The very uniqueness of the signal compels us toward exotic explanations like flares or bursts.
Well, here it's best to explain this by showing you this picture and this schematic. Here, all of the signs point at this being a somewhat unusual, somewhat rare, but also extremely powerful astrophysical event. And most likely what's known as a maser flare, also referred to as superradiance burst, from some kind of a small, cold, neutral hydrogen cloud, like the one you see right here. Or as someone described it in the previous video that I made approximately a few months ago, this was basically a hydrogen cloud fart. But in this case, a hydrogen fart produced as a result of some kind of a powerful object, such as for example a magnetar, illuminating the source from a slightly different angle. And so here you can kind of compare this to a very powerful laser shooting at a cloud and making the cloud suddenly brighten up in certain frequencies. And because this was a hydrogen cloud, it produced what's known as a hydrogen line. But much more importantly, this is not a new idea. This is actually a confirmation of a previous proposition as well, where researchers were even able to confirm this by observing so much similar events coming from different clouds that were producing extremely similar emissions, but just not as powerful.
But let's not overlook the role of hydrogen clouds. They're cosmic canvases waiting for energy to paint them. The magnetar-triggered superradiance idea fits elegantly, tying together known astrophysics with this otherwise baffling single event.
And so in some sense, this is a major confirmation for this really intriguing proposition from something like a year ago. Which of course suggests that these cold hydrogen clouds seem to be able to produce these very powerful emissions that possibly mimic communication from civilizations that we've been searching for since the beginning of SETI. And because the newly calculated velocity of 74 km per second actually matches other similar clouds, right now this seems to be the best possible explanation. And many such concentrations of hydrogen gas exist in the galactic halo and actually pretty much all over the place, usually produced by very powerful emissions from very massive stars that are either about to go supernova or are about to become white dwarfs, neutron stars, or black holes, with most of them leaving behind these extremely large clouds, moving at velocities of 25 to 90 km per second.
Frankly speaking, the enthusiasm here is contagious yet sobering. If cold hydrogen clouds can masquerade as alien beacons, then SETI faces a trickier landscape. Natural imposters may be plentiful, but understanding them enriches astrophysics nonetheless.
And we've actually discussed one of the recent discoveries from a few hundred light years away from us that seems to directly mimic one of these clouds and was actually discovered completely by accident. But in this case, it's in a different position from the WOW signal, and so we don't think it was produced by that cloud. But this just proves that these clouds are all over the place, and when something very powerful shines on them, they can occasionally produce these very powerful radio emissions. But there's maybe one small problem with this explanation right now. At the moment, none of these clouds, or at least the ones we know of, have been able to produce anything as powerful as the WOW signal, because at 250 Janskis, this makes it truly exceptional. And so there is still definitely a bit of a mystery, and there's maybe still a tiny chance that this is aliens after all. Probably not, but maybe. Which means that in the next few months, possibly the next few years, we'll hear more about this event and potential explanations, or possibly some other explanations involving something entirely different. So this is definitely not the end of the story yet. But I guess even more importantly, we now are pretty certain it was not some kind of a radio source coming from our own planet. It was definitely not satellites, and not emissions coming from the moon or the sun, and indeed seems to be something from very far away, from some kind of an astrophysical source. With this incredible work also serving as a really important reminder that some of the most surprising discoveries are basically hidden in plain sight, waiting to be unlocked with new perspectives and new analytical tools. But I guess for now, that's all I wanted to mention. Stay wonderful, I'll see you tomorrow, and as always, bye-bye.
Let's be honest, in the grand scheme of the universe, this mystery remains a gem. Even if hydrogen flares explain much, the WOW signal still teases us with possibility. And Anton is right. New tools often breathe fresh life into old puzzles, keeping astronomy vibrant